there, everyone. We're going to go ahead and open up the Zoom room and let people start coming in. Thank you so much for joining us this morning. As you're getting settled in, go ahead and navigate to the chat window in the bottom of your Zoom window. I'd love to hear whether you've been to a Vernier webinar, and also let me know what the weather is like there. We are having a very Pacific Northwest, foggy, rainy morning. And so if you are having a hot Arizona morning or a cold Alaskan morning, let me know. I'm interested to see. And just make sure that your chats are set to everyone so that anyone who's kind of keeping an eye on the chat box can see. That also helps when we're answering questions so that if we refer to your question in the chat box, people know what we're saying. So go ahead and let us know if this is your first Vernier webinar, if you've been here before, and what the weather is like in the part of the world you're in. Yep, News had a foggy bike ride to work this morning. Awesome.
Yeah.
Josh, thank you so much for joining us again. Oh, and you're in Portland, Maine, so it's cloudy on both sides of the Portland spectrum.
Yep.
That's awesome. Hey, Cindy, thank you so much for joining us. It looks like it's your first time. This is going to be exciting. Sunny day. Very nice. Teresa, thank you so much for joining us. First Vernier webinar, and it's kind of cloudy, rainy. Well, I guess fall has fallen, huh? It's kind of rainy for everybody. Oh my gosh, Jennifer, I can't even imagine how beautiful the fall foliage is in Vermont. That is like on my bucket list. How great. Awesome. Well, thank you all for joining us. Maybe to make the most of the time we have today, we can hop right in. So thank you all for joining us for From Sparks to Spectacular Data, Exploring Hess's Law and the Heat of Combustion of Magnesium. Go ahead and if you are running graphical analysis in your browser, you can go to graphicalanalysis.app and get started with that. And I think on the next slide, we just have some housekeeping items.
Oh, that's Dylan's cue for me to do some stuff here.
Yeah.
Housekeeping items. There you go, Dylan.
Perfect. Thank you, Nus. So just some stuff I want you all to know before we get started. You will absolutely have a recording of this webinar. As soon as it's edited and live, you'll be able to find it on both our website and our YouTube channel. It typically takes about 3 to 5 business days for that to be posted. And as soon as that is available, you will also receive an email with the recording link. So you'll have that in your inbox available to watch at your own leisure. And you will also get the public folder with additional resources and a certificate of attendance. I'll drop that in the chat here in a moment too, but you'll get that again to your inbox. We'd love to answer your questions during today's session, so please use that chat section that we are already, popping into right now and ask us your questions. We are available. If we happen to skip your question or don't get to it, please reach out to us at chemistry@vernier.com. We'd love to circle back and talk to you. And I think that is, I am now passing it off to Nus and Melissa. Thank you all so much for joining us.
Hi, good morning, folks. My name is Nüsret Hisim, and I'm going to be running it from this end and hopefully get some of you guys to get some live data on your end. I taught chemistry and physics in Maryland for 34 years, used Vernier stuff almost from the beginning. 1984 was when I first met David Vernier by telephone. And then I've been at the office now since 16. Doing webinars and writing curriculum and doing trainings so it's been a lot of fun. It's been a blast. Hey, Melissa, do you want to say a little bit about yourself?
Sure, yeah. Hi, everyone. I'm also one of the chemists here at Vernier. I've been at the company now a little over 13 years, and before that, I taught chemistry at the college level. Yeah, and I am here as the support for Nus. He's going to be running the show, but if you have any questions whatsoever, just put them in the chat, and we will get to them as we go. But other than that, take it away.
All right, here we go. All right. So Today what we're going to do is we're going to do this spectacular, what did Dylan call it? Sparks Spectacular Exploring Hess's Law. Okay, so that's what we're going to do. So one of the very earliest experiment, I don't know if we'll call it experiment or reaction that my students do is this one. And what's cool about it is, well, of course students are super excited to do this, right? It's just yeah, burn some magnesium, and it fits into so many places, endothermic, exothermic, synthesis reactions. The magnesium oxide is great for doing metal oxide plus water, and so you can do you can teach a lot with this. I use the magnesium ribbons as fuses for when we do thermite, to light they don't light up a thermite reaction. So it's a wonderful thing. But you're teaching just calorimetry in general, right? So heats of reaction, or just energy of reactions. And you might ask your students, like, how would we measure the actual amount of energy that was given off by this reaction? And you're going to get all kinds of of responses. I think it would be wonderful just to do that, just present that with them and say, okay, we know energy is being given off, but is there a way that we could measure the amount of energy that was given off by this reaction? And so that would be my challenge. And it's a calorimetry experiment, but the neat thing about it is it's counterintuitive, right? The kids are going to want to stick probes in there, they're going to want to stick thermometers in there, they're going to want to drop that in water or something, right? So how are they going to do that? So what we're going to do is there's a very fun experiment. I don't know. Well, leave you to decide if it's fun. But there's an experiment in one of our chemistry books, that does calorimetry, but also incorporates Hess's law. And so, we'll see that in a minute. And what I'm going to do is I did a couple things to make it a little easier on your end. One is that I can share data with you. So you can get live data from me. This will demonstrate how that feature of graphical analysis works. And it'll work on any device. If you have a second, ideally, if you have a second computer or Chromebook, you could run graphical analysis from the web. You can just go to graphicalanalysis.app and just run it. If you're on a phone, like here's my phone, you are going to have to go to the store for that phone to get graphical analysis, Android or Apple, or something like the iPad, that kind of thing. But if you have a copy of it handy, that would be ideal. And what we're going to do is we're going to use this code to make it a pro version of graphical analysis. So let's go ahead and set that up, and then we'll do the experiment. And you don't have to do this at all, right? You're welcome to just watch. But if you want to get live data, I mean, I'm seeing Ohio and Vermont and all over the country, and so yeah, it's kind of cool. I did some teachers in Malawi in Africa last week, and it was just kind of neat, that we could share this everywhere. So open your copy of graphical analysis and drop that code. Melissa or Dylan, if you could pop it back into the chat again, that would probably be the easiest way for people to see it. And just put that in this where it says license key, and then tap submit, and your copy of graphical analysis will become the pro copy. By the way, use this with your students. It's not just for you. If you want to try it and just see how it works in your classroom, by all means, Mac, Windows, Chromebook, iPad, everything will work with this. Hit submit, and if I did it right, yeah, it tells me that this is good for a couple of weeks. And so we'll give that to you guys so that you can follow along. Let me get the experiment set up, and then we'll do it. Okay, so in our chemistry with Vernier book, and experiment number 19, this is the setup of the experiment, and we're going to do these two reactions right here, number 1 and number 2. We're going to do those. And so the first part of the experiment is for students to manipulate those reactions. And on the third one, they're going to be given the delta H for that reaction. It's here in the description. And their job is to manipulate these three, Hess's law, manipulate them so that when what you end up with is magnesium burning to make magnesium oxide, right? And so the pre-lab, that's exactly what they have to do. They have to do that. Now, what I did for us today, because we don't have very long in the webinar, is I created a spreadsheet, and it's in the shared folder, so you guys will have access to this too. And there is the pre-lab right there. And of course, when you get our lab manual, you automatically get all the teacher stuff. So this would also be in the teacher pages. And so you can download them for for Logger Pro or for graphical analysis or LabQuest. I mean, every way you can do it. Somebody sent a question about, can I do this with Logger Pro? Absolutely, yeah, you can do this with, but we're getting to the point where a lot of schools now are switching over to graphical analysis for whatever reason that we won't get too deep into today. And so that's what we're going to do today. So let's take a look at that experiment again, and I'll get everything running here. We're going to do 2 runs. What we're going to do is I'm going to show you how to set up, if you've never seen it before, how to set up graphical analysis. And then we're going to do 2 reactions, and I'll share the data with you, and we'll go from there. So let me get this set up. So you could, for the moment, just watch. You're going to get all this automatically in just a second. In the instructions, it says that we want to make the mode setting go for 1 reading a second, and we want that for 480 seconds. For us today, we're not going to wait all that long, just because it takes a little bit of time that I don't want to lose. But you'll get the idea for sure. We'll see how my percent error comes out at the end. I'm going to take a temperature probe, so I'm going to turn it on. All the GoDirect sensors work the same way. They have a red LED that indicates that this is ready to pair. I'm going to tap sensor data collection. And graphical analysis is going to be looking for the options. I'm at the office, so there's a million things nearby. On the back of every sensor, sometimes on the back, sometimes on the front, there's an ID number. This one ends in the letters N and 8. So in this filter box, especially if you're in your classroom and you've got a whole bunch of things coming up, you can narrow down the field a whole lot. And I'm going to connect to it. Notice that the red LED now turned green. That indicates that I'm connected to it. No one else can connect to it. Okay, so that's ready to roll. I'm going to turn this red bar off here a little bit. And so now what I'm going to do is set the experiment up so that we can collect our data. So bottom left corner where it says mode, I'm going to change this to, I'm going to leave it on time-based, but those of you, that might do a titration or some other experiment that doesn't need time, this is where you would set that. I'm going to set this to 1 reading a second, like it says in the experiment, and I'm going to set it for 480 seconds, but we'll be able to stop it early if we need to. Another thing I'm going to do is I'm going to turn on a meter, just because that little one at the bottom is just a little bit, not super duper size. So I kind of like to have it a little bit bigger. I'm going to put it in this little electrode support so I don't have to mess with it too much. And so the plan here is that if you follow the instructions in the experiment, we're going to put some hydrochloric acid in the cup, and then we're going to add, in the first reaction, we're going to add magnesium oxide to it. And let me triple check that I make sure I don't mess things up here. 100 milliliters and 1 gram of magnesium oxide. Okay, so let's get that all set up, and then we'll start collecting data with you. I have a little balance set up here just to make it a little bit easier. One thing to think about, we'll talk about with the magnesium in a bit. So I'm going to get it. So what I'm going to do is I'm going to, my stir's in there already. I'm going to go ahead and weigh it and then tare the value. And so, because if you think about it, calorimetry calculations, it's going to be, Q equals MC delta T, not volume. So let's see if I can how well I can do this. You're going to be testing my skill here. There's a little delay, so I want to make sure I don't go too far over or under 100. You know, 100 milliliters, we're making, if you do it that way, you're making the assumption that the density is 1, which, you know, probably to 1 or 2 significant figures it is. But okay, here we go, getting close here. So let's see if I can kind of be close. Of course, the hydrochloric acid is in excess, so you know it's not going to be really critical that I be right at 100, but I'm going to try to be close. All right, there we go. That's good. So let me jot that down real quick because we're going to need that later on. So the HCl is 101.98 grams. Okay. And you know, like I said, you could do it by volume, of course, and just make that assumption that's not too bad, actually. All right, let's put him in I'm going to put it in this 400 milliliter beaker just to kind of keep things from tipping over, especially in here. My colleagues in physics probably won't appreciate if I dump too much chemicals on our nice studio. Magnesium oxide, here we go. Lab said to take a gram. Once again, it's, you know, it's sometimes for kids, it's like, oh, I got to get exactly a gram. We need to know the mass, but you know, if we're off by a little bit, that's not going to kill, that's not going to ruin the experiment. So let's see, there's half a gram-ish. Let's get another half a gram-ish. Just need to know the value. And we'll jot that one down once I have it. Come on, baby. Oh, look at that, 0.9. I'm pretty close. Let's see if I can, how close I can get to a gram there. Once again, you know, I could spend a long time doing this or I could not. It's all right, 0.98. All right, sounds good. Let's write that down. We're going to do that in a spreadsheet. So MgO 0.98 grams. Okay. All right.
Would you take
Yes.
a quick second to describe how you have the OHAS balance connected to the LabQuest?
Sure, sure. So we sell a limited number of O houses. This one is probably the cheapest of the lot, 400 gram to plus or minus 0.01. And if you want to connect them to a computer or to now right now, the only thing that works on a computer is Logger Pro, but or actually I don't, yeah, it works. Or to a LabQuest, LabQuest 2, LabQuest 3, you have to buy a separate USB adapter. That's this doodad back here. And then that gives you a USB plug that you can plug in. The other thing that when you get them from us, OHAUS has a million ways you can set these things up. And so we make sure that when you get it from us, it's ready to go. Okay, so when you plug in the cable, it's going to work. There are other O houses with the USB adapter could work. The older ones do to some extent, but we can't guarantee it. So, you know, if you buy a different model, if you look on our website, you can look at the models and much of the model number matches up with other O houses. But if you buy one that doesn't, just be forewarned that I've had some customers with good success and some customers with less than good success. So I just want to let you know about that. I'm going to start the stir. I'm going to lower the probe into the liquid. Let me see how this is going to fit. You know, I was kind of figuring out, do you need this? Somebody asked me that. It can't hurt, that's for sure. So we're ready to go here. I want to wait till the temperature is level. So while I'm doing that, let's connect to you. What I need you to do, let me bring my my phone over. On your end, if you want to share data with us, what I need you to do is open your copy of Graphical Analysis and tap where it says data sharing. So I'm going to tap there on my phone. Okay. And then this box right here says enter the source. Make sure that it's on the line that says online. You have to have a pro version for this. So if you try to do this with the free version, it won't work. It'll tell you have to have the pro version. And what I'm going to do is I'm the source of the data. So I'm going to go up here to the TIE Fighter. I call it a TIE Fighter. I think it's like some other name, but it's sharing session. Okay, so I'm going to start that and we're going to get that code. So if you're following along, let me make it big so everybody can see it. we told the programmers, we're on a phone. We need to be able to type this in easy, right? So no uppercase and no weird letters that look like two different letters. And, we try to make it, relatively straightforward. So what that's going to do is that's going to connect you to me through the internet. So I'm going to tap connect, and if everything works the way it should work, look at that temperature, right? So it's basically set up to go. Let me slide him out of the way so that we'll bring him back later if we need to see him. So this guy, you'll need to put that in, and I think Melissa or somebody's probably grabbed it already. So I'm going to close this window. And then what I'm going to do is I'm going to give it, all that little song and dance was so that the temperature would level out. I'm going to start collecting some data. You should see an inchworm start appearing on your screen. So if you see a little inchworm appearing on your screen, give us a little thumbs up in the chat. We love to see
I
it.
got it. It's on my screen.
Yay. Anybody else? Vermont,
Yeah.
Ohio.
Yay.
Everybody
People
else, you
are
getting some
getting it.
data? All right.
Yep.
I'm talking. I need to do the experiment. I've got this spinning. I'm going to go ahead and drop the magnesium oxide in. And let me get the top on here. All right. And let's see what happens. So it looks like something's going on. I think the temperature is starting to go up. So the plan here is, let's kind of walk it through while we're waiting, is the plan here is that you would try to get the maximum temperature, right? And so that's the reason for the 480 seconds. I may, once it starts to look like it's maxing out, I'll flip it, probably stop it, and we'll maybe, you guys will have the spreadsheet. So if you want to fiddle a little bit and see, well, gee, if we had waited an extra, but the deal here is that we're increasing the temperature at its exothermic reaction, and we're going to use that to do a calculation. And while this is being so exciting, I'm going to switch over to the spreadsheet so that we can at least put some numbers in. Reaction number one, what was the mass of the HCl? Well, it was 101.98. Let's see, we don't know the temperatures yet. Mass of the solid was 0.98 grams. Okay, and so we'll see how that goes as far as the calculations go. I locked the sheet, so everything that's green you can change. Everything that's not green, it'll yell at you. Google will yell at you and say, "Hey, do you really want to change that?" So it'll do the calculations for it. So this is the basic heat calculation. Convert that to delta H, and then we'll calculate the number of moles. Actually, that's probably, at least for this reaction, that's already done, right? The number of moles of magnesium oxide that we used. We don't know this yet because we don't know the temperature change. So we'll see how that goes. Let me go back. Anybody have any thoughts or questions while we're waiting for this thing to max out? Quiet. Internet crickets.
Everyone's just waiting to see what happens.
Yeah, hold me back, right? Well, what I could do to save a minute is I could work on the magnesium. Guys, we're going to need that for part 2. So we'll let this go. It looks like it's pretty close, but we'll let that go because I have to do the magnesium anyway. So might as well do that. Let's take a look. I think it's half a gram. And so it says repeat steps 5 through 10 with half a gram of magnesium ribbon. And so I want to show you a trick that I think one of the guys here at Vernier taught it to me, years ago. It's like, balances have definitely gotten more affordable by far. You can get a cheapo balance, that'll measure even to a milligram, and not that expensive. But what if you don't have those, or kids don't have it at every station or something like that? One thing to think about is measure a lot of magnesium carefully. Right, so this piece of magnesium in here is 1.00 millimeters, and you weigh it, it's 1.32 grams. So, you give the students, you could give them pre-weighed magnesium, you could do it with them, you could cut the pieces up and give them this data so they can convert it to the length to mass, but that's a way around maybe having a balance at every station. So something to think about. I need for part 2, I need a half gram of magnesium. So what I was doing here, and I wanted to show it to you, this magnesium has lived a hard life here at the office. And so I was scraping it to kind of get some of the oxide off. I use these when I do electrochem too, to clean electrodes. These are just leftover tiles from a kitchen remodel I did, I don't know, few years ago. So, very handy to have, if you have little extra pieces like that. So we need a half a gram. So let's see. So part 2, they put some other pieces here that I cleaned up earlier. There's 0.46. There we go. That's pretty good. Okay, let me stop wiggling around here. All right. So for part 2, for magnesium, it's going to be 0.52 grams. Okay, and we don't know the HCl yet because we're still in the middle of the last reaction. Okay, so that's ready. Oh, it looks like it's maxed out for sure. Okay, so I'm going to stop collecting data. And, if you needed to, we could keep going. But I know for our purposes today, I think it'll be good. Maximum temperature on your end, you can do the same thing. Tap at the end at 28.7, initial temperature 22.9. If you're doing a lot of runs, if you tap on the bottom left, there's a little graph options tool. And let me pull this up so that the temp probe can return back to room temperature while I'm talking. There's a little statistics tool at the bottom left corner there. Tap on that, choose statistics. It'll even do delta T for you, but you may or may not want that to happen. But there's the the minimum value 22.8, maximum value 28.758. I mean, I'll let you decide on significant figures. Let's go put those in the spreadsheet, and then we'll move. Well, actually, no. What we'll do is I'm going to write them down. So because I want to get that other reaction going. So we have T initial, T final. So that's T initial 22.844. We can argue about sig figs later. 28.758. Okay, that's done. All right. So let's get the second half of the reaction set up. And one thing about graphical analysis is when you do a second run, it automatically stores the first one. So it's kind of neat in that sense. So for our sake today, I was lazy and I set up a second cup so that we would not have to, oh, this is the magnesium from what we're going to need later. I'm going to stick it over here so I don't lose it. So, that way I wouldn't have to mess with it. All right, let's tear that out. Come on, baby. There we go. Let me get 100 milliliters of hydrochloric acid, and then we can talk while that second one runs. I think that second one goes faster though. 100 mils. Okay, here we go. 53, 61. I'm going to get cocky here and go way over, so I got to be careful. Kind of get cowboy after a while. All right, there we go. 93. So let's see if I can get close to 100. Thinking about it later now, a little barrel pipette would have been smart. Too late. 97. It's still in excess. So, oh, 99 point. Look at that. Look at that. I better not tempt the fates here. So 99.87 HCl, 99.87 grams. Okay. All right. Put that in here. Let's let the temperature probe find its. Let me get that spinning a little bit. Get that temperature probe down in there. Let him kind of find his temperature. Okay. Magnesium is ready. This is ready. I'm watching the temperature just to see that it's kind of not going up and down too much. And it looks good. Let's hit collect. So on your end, it should look similar to on my end. You should see a different color inchworm starting to come across. Let me get the magnesium in there. It would have been cool. It just occurred to me. Anyway, we'll talk about it after I get the magnesium in. All right, so let me get all the magnesium in there. Okay, I'm dropping in the magnesium. Hopefully it'll all go in the cup and not all over the table. And then let me put the lid on. Would have been fun to make a prediction, have the kids the built into graphical analysis is this option to make predictions. And so, it might have been cool to say, hey, what do you think it's going to look like with magnesium? Is the temperature change going to be greater? Is the temperature change going to be less? And the thing about predictions, the prediction mode is in the bottom left here in the graph options. There's a thing here where you can add a prediction. And it might have been kind of cool just to see, well, gee, I wonder, how much, how they compare, and I would, it'd be kind of neat. All of our software has the ability to make predictions. So when I was teaching, I used to do it on Logger Pro. And the students were just in terror, right? They were, Mr. Hisim, what if we get our prediction wrong? Said the only time you lose points is if I don't see it on your graph, right? You get it wrong. Think about it. Scientists get predictions wrong 99% of the time. That's the whole point. And then they just change their experiment to try to see if they can, and make a new prediction based on that. So, but my students were just in fear that, they would somehow lose points because of the prediction. Anyway, where is the other data? Because we get this call, my students did a titration yesterday, and then they did another one, and we lost the first one. No, you didn't. Tap on the y-axis label. I think when I'm sharing with you guys, I think this will do it automatically. But there's trial number 1. And so if we tap, this little doodad here, a little switch, then it'll come up so you can kind of compare the two if you wanted to. And if you had your prediction in there, of course, it would show that. These can be renamed too. So you can go on the data table and you can rename these. While I'm collecting data, it won't let me rename them, but I'll show you. I'm running short on time and I don't want to kill all our time doing this stuff. But if you're in the data table, and you click next to, let me give it a little space here. If you click next to where it says data set, there's 3 little dots. Right now they're gray because I'm collecting data. But if I click on that, it allows me to either delete it or rename it. So I could call that one MGO or something like that. So then it would stand out. If you do a graph legend, which is another option, right, in the graph options. Right now, it just says data set 1 or 2, but if you rename them, it'll say MGO, magnesium, whatever you want, you can rename it. Oh, look at that, maxed out. Perfect. That was some pretty good song and dance, right, Melissa?
Yeah, that looks pretty good. Would you comment on the lid that you're using? Do you think it's necessary? Is our students going to get better data?
I don't know. Somebody's actually asked that question. Didn't we talk about a calorimeter at one point? I remember we were banging that around. I don't know for a fact that it's going to be better data. My intuition is that it's going to be better data, but honestly, this thing's wide open to the world, and so I can't imagine that. If you're doing constant pressure. Technical term, right? If you're doing constant pressure calorimetry, not a bomb calorimeter. Someone asked about a bomb calorimeter, not my high school. Most cases you're open to the world. I mean, if maybe 2 cups would be better. Somebody asked that, I think. But honestly, I think for most of the things we do, we'll see here. We'll throw these numbers in a second. Yeah. Most of the things we do, even with the lid off, I think we get okay data.
Yeah. I think it would. And these reactions are so different too. Look at the temperature change. It's going to be a pretty minimal difference with and without the lid. But hey, something to test out.
I really think I agree with you. Yeah, let's get that stat. See, we only have 10 minutes, and I want to give time for any discussion. Please throw it in the chat, and we'll get to it if we can. If I have both graphs on the screen, it does show both of them at the same time, but what's nice is it color codes them. So the second run was this kind of goldish yellow run. So minimum temp, let me get it up here. Temp initial was 23 point, check that out, 23.000. How many times does that happen? And then temp final, oh, wait a minute. Yeah, 44.48. Okay, temp final, 44.438. Okay, let's go through all these numbers in the sheet and let's see. I don't know, crossing my fingers. I don't know, me talking and all this kind of stuff, whether it'll be any good or not. Let's see. So let's see. We had 99.87. That's pretty close to this thing I did at the office the other day. Just like a lot of you, I do stuff in advance. You know, I want to make sure that everything's working. 0.52 was the mass. Final temp was 44.438. And the initial temperature was 23 even. All right, that looks bad. Let me make it look better. Oh, good old Google, right? It's, hey, you don't, zeros don't count, right? This is, so anyway, let's see. Oh my gosh, hold me back. All right, the lid matters.
That's really good percent error.
That's a pretty, you know, if I was under 10, I was happy. If I was under 5, I was ecstatic. I mean, here I am with all you guys watching. Yeah, and I got 1.9%.
You do get the best data during webinars. It's really true.
I think,
I
you know,
save all your webinar data because it's always the prettiest.
it's just crazy stuff. Yeah.
I do want to point out though, you did keep saying temp final and you were using temp max because a couple people noticed that the temperature started to decrease. So it's temp max, not temp final. So
you know, I used to teach delta T as T final minus T initial. I just did that all the time, but you're absolutely right. In this case, it would be not T final because that would be way out over here. So you're totally right about that. Especially when you have one that, like this, that's dramatically different, you know, from the max and the final. You would definitely want to point that out. Does it say that? I don't know what it says in the instructions. I
do think it's habit, a little old school habit to say temp final.
Yeah, let's see. What do we put in our data table here?
Oh, we do say final.
We do say final, don't we? You know why? Because that's old school. And we need some of you young bucks to catch us and say, hey, that needs to be the right. Okay. But good catch.
Yeah.
Thank you. So anyway, so here was the thought and the reason why we chose this one. You know, you're doing temperature probes and we do get a lot of like, you know, temperature probe, pretty simple probe. You know, what are you going to do with a temperature probe? In chemistry, lot of calorimetry experiments, right? You can do heat of combustion. I wrote in both new books that I wrote, I'm saying I wrote, but we wrote when the GC experiment, that was Melissa, because I like, oh, but there are some calorimetry experiments like heat of combustion. In the forensics book, I called it the burning accelerants. In the food book, I just called it like the energy from food or something like that. But that's a calorimetry experiment. So not unusual to do and relatively easy. And you guys saw the data wasn't horrible with a styrofoam cup, you know. So do you need a super duper fancy calorimeter? Probably not. You know, probably get by. You know, you certainly teach the concept pretty well, and if you can pull off data like this, I will tell you the heat of combustion experiments. That's the one where you're burning a fuel or burning a food. The food one, you burn chips. In the I stopped burning nuts because so many kids were allergic. So I switched over to burning chips, and you got to be careful, but you know, it turned out that those were a little safer. And then in the forensics book, we're burning fuel. So, and the fuels are like, you know, ethanol and propanol, things like that. The problem with that is that not all the heat transfers to the water, and you got that metal in the can, and it's got its own, you know, CP, and so if you want to take that into account, you got to weigh the can, and you're losing a lot of heat to the air. So those, it's very hard to get this kind of results with that experiment. But you know, it teaches the concept pretty well, and if you want to talk about bomb calorimetry, you know, you can kind of put a bomb up and you can say, hey, you burn it and everything goes into the water, or mostly. So we did have someone ask about, can you use, you know, our temp probes in a bomb? You can. Some schools do. The wide range bomb or wide range temp is a longer shaft, and so it can reach down further into the bomb. I just got to seal it in there because, you know, you're building up. That is not a constant pressure. That has a constant volume. So, you know, you got to be a little more careful with the setup, but it's not impossible that you could use our stuff. We got about 5 minutes. I don't know. Do we have anything else on the spreadsheet? Let me make sure. I tend to lose track of my lesson plan here. Foam cup.
I do want to point out, I think Nus said it, but I want to reiterate, the styrofoam cup is reusable. So definitely, you know, rinse it out, reuse it. for all the class periods you have for next semester. I know I've gotten a lot of feedback from people
Yeah.
that styrofoam cups are getting a lot harder to find, for good reason. So definitely reuse them as much as you can. I know after a few years you can't, but try and reuse
I,
them as much as you can.
I kept them in my classroom. I kept them in the cabinet with the beakers.
Yeah.
You know, they were in the back, and you know, we just used them all the time. But yeah, it is get there are some other alternatives, like they have some paper cups. I found that those, I mean, that data that you saw, that was done with a paper cup. And so, you know, I think the foam is still, you know, giving me better, I'm thinking it's giving me better data. But like Melissa said, there's no reason to throw them away. Kids will do that, right? They're done, they
Mhm.
throw them in the trash. I would walk around my classroom and fish them out of the trash, rinse them, and you know, as long as they don't poke a hole in them. And it depends on the students, but sometimes they will, you know. So, but yeah, absolutely, use them over and over again. You're going to for this type of calorimetry experiment, they're perfect. Heat of reaction, heat of solution, right? If you're an AP teacher, I forget which experiment it is, but there's a hand warmer experiment, which is a heat of solution experiment, and you'll use them for those. So lots of good applications for that, and also for using a temp probe in every level of science. We have in our middle school or physical science book a very nice endothermic exothermic experiment. You would also do that in a um, foam cup, you know. So so absolutely encourage that. Keep throwing those questions. If you have any questions up there, as far as graphical analysis goes, if you like this data, I like this data. I'm going to go up here and I'm going to save it. Okay. And so it's that one word of minor caution to you Chromebook users. If the kids own Chromebook, it's less trouble if it's the one that they're using all the time. But if it's a classroom one, be careful. When you go to save, it defaults to the download folder that's on the Chromebook. I've had this call before where, you know, my kids did an experiment yesterday and now they can't find the data. Well, it's on that other Chromebook. What you need to do is save it to my drive. If you save it to my drive, then that file goes with you. You can open my drive anywhere you want. But be aware of that, that when you go to save data on your platform, you know, you need to maybe practice that a little bit. CWV, let's see, this one is heat of combustion. I'm going to put this in a safe place, my desktop, temporarily, and I'll put it in our shared folder later. So that's one thing to be aware of is what, you know, when you're saving it. You iOS users, you need to practice saving, because the way Apple does things is a little different than the way the rest of the human body wants to do things. So just be aware of that. Find the Files app on your iOS device. Very, very, very handy. So all of this can be, you know, can be saved, and you can modify these 27 ways from Sunday in terms of display. You can have two graphs if you want to have, you know, different graphs to show the different reactions. Let me get that out of the way. So we could have, you know, the first one in the top graph. We could have the second one in the bottom graph. Highly recommend that you play around with it. Your students play around with it. These can be labeled. They can be annotated. Each one can have its own statistics. The other thing you need to practice, if you haven't used graphical analysis, is you need to practice making reports. So when you're making reports in graphical analysis, we provide you standard formats for pulling the graphs out. That's for free. You pro users, all of you now, also have a PDF option. The beauty of that is that then both graphs are on one file instead of being in separate files. So you know, that's something to think about, but you need to practice this. These graph options that we have, you can copy them. We even gave you a little copy icon here. And in the shared folder, I put, so the last 3 years I taught, I was teaching forensic science, and we had no lab manual. We had no anything. I developed everything myself. And so one thing that I did was we were Google school. So I had my students create actually lab reports. My favorite was using what's this PowerPoint name of Google. It's not Sheets. It's you know what I mean. I can't think of it right now. But the neat thing is that that file format that you're saving files or creating files in graphical analysis, totally compatible with whatever platform you're on. So creating reports is super easy. So my students were doing that, you know, with even in the Google classroom. So we are out of time. If you have any questions, please contact us. Chemistry@vernier.com comes right to Melissa and I. And you know, we're happy. Call us. Love to talk to you. But let us know how we can help. Okay, Dylan, is there anything else we need to do?
Looks good. Thank you all so much for joining us today.
Yeah.
All right.
Thanks,
Bye, all.
everyone.
Bye.
Bye.